All right, picking up on this last example where we left off. So we've got the totals for uh, women who have ovarian cancer and women who do not have ovarian cancer. And then this test developed that correctly detects the presence of ovarian cancer 99.97% of the time. So if they have ovarian cancer, this gives you a positive test 99.97% of the time. So that's going to be, and I'm going to write this up here, 0.9997 times the probability that they have it, 0.0002. And when we do that, let's see, 0.9997 times 0.0002. That ends up being 0.00019994. So subtracting that from the 0.0002, so this is going to be 0.002 minus 0.00019994, we get 0.002 minus that answer. Oh, sorry, I accidentally did times that answer, 0.00. I left off a 0, that's what happened. 0002 minus that answer. Is 0.1234 7 zeros, 5, 6, 7, 6. Then it says, unfortunately, it also gives 5% false positives. So that's no cancer, but a positive. So 5% of the people who don't have cancer are going to get a positive test here. So this is going to be 0.05 times the 0.9998. And that comes out to be 0.4999. Subtracting that from the 0.9998, we end up with 0.94981. So just in looking at this, the majority of what's going to happen is we're going to get no cancer and a negative test almost 95% of the time. They don't have cancer and they're going to get a negative test. Unfortunately, notice that almost 5% of the time they're not going to have cancer, but they're going to get a positive test. All right, so let's see if we have enough to find this quantity. So that's going to be the probability that they have cancer and they have a positive test divided by the probability that they have a positive test. So I need to add these two pieces together. I don't need to find this one. So adding these two pieces together, this is the 0.00019994 plus 0.04999, and that ends up being 0.050189994. So this is both, they have cancer and they have a positive test. It's not very likely. Of course, it's not very likely that they have the cancer at all. Divided by 0.04999. And it turns out, oh, sorry, wrong one, this one, 0.050189994. There we go. That comes out to be 0.00398. So about 0.4% of the time. Notice again, this is a really good and effective test. But if it says that you have cancer, there's only about a 0.4% chance that you actually do have cancer. So again, as we discussed the other day, when you do a test like this, you almost always have to do additional testing. You get, frequently a doctor will talk about your preliminary diagnosis is that you have ovarian cancer, but we want to do more tests in order to be sure. Okay, that's it for this.